So a while ago, I had these tiny little OLED in a mailbag, and I said I would do a review later on. And yeah, well, this is the review, the mailbag card link. Yeah, so I will have, of course, a look at the display quality, but then in detail the measurements, if you want to put that into a case, uh, and some thoughts about that. Yeah, how to connect it to the Arduino. That's just triviality. I will only skim over that. And of course, the library I used to get that thing working on the first try. Yeah, so first things first, the good news, it's working. And now let's dig into it. So the most important thing, of course, is the display quality. Can I get a focus? Yes. So display quality is good, and what you see here, I can a big thumb here, that is actually the size of the display area. So it's not the whole glass substrate, it's really only this area. And since it's an OLED, angle of view is, yeah, enormous, really enormous in all dimensions. Oh, yeah, and I removed the protective cover. Um, so yeah, that's very nice. So in that respect, it's perfect. Yeah. About the measurements. Give me a second. So that's the footprint, respectively pattern I created for that part. Yeah, all measurements are in inches. So basically, the board itself is just 0.48 inches by 1.5 inches. Okay, you can read for yourself. You have with 0.1 inch distance here the headers, and they are away from the board edge 0.06 inches. And yeah, and inside that you have this really small, and yeah, that's just my drawing. That should be 0.91 inches in diagonal. The display itself. And yeah, I know it's upside down, top. What can I do? I didn't want to, yeah, start afresh or rotate the whole thing and scramble all my dimensions. Yeah, that tiny display area, 0.91 inch in diagonal or 0.88 width, and the height 0.22 inches. And that itself, yeah, the display area is on a glass substrate or glass carrier. And that is much larger, takes up almost the whole board, as you can see. That's 1.18 inches by 0.43 5 inches. Okay, I'll put a second printout with the millimeters so you can have a look at it, stop the video, and so on. I will show that later. Yeah, there are. You have to take these measurements with a grain of salt, because yeah, the glass substrate is glued to the board, and yeah, give it all plus minus half a millimeter, and that's the reason that small line is in there. That basically has a 1 millimeter distance to the display area, and that would be the cutout I would recommend to put into a case for the display, but more on that later. And then we have yeah, a flat cable connector, very small flat cable connector here. This is also quite an annoyance. I don't know, but yeah, you have to watch out for that. So yeah, have a look at it. I take my hand out of the view. You can take a screenshot or whatever. Let's have a look at that in millimeters. Again, hands out of view, can take a screenshot, and yeah. So how would you put that thing into a case? That's a good question. Well, there are I wouldn't say problems, but a few constraints. If you look at it from the side, you see that flat cable is stretching over right to the edge of the board. And you have, okay, you might find another solution here, but you have also these pins, which, yeah, I have to shorten a little bit. But the bottom line is there's probably no way you can just make a cutout for the whole glass substrate. And yeah, really get it a little bit into the material of your case. That won't work. Yeah, I will draw later on what I mean. What you have to do is probably just make a cutout for the viewing area, and yeah, file that down a little bit at an angle at the edges. I'll draw that just in a second. Yeah, I mean, that's a drawback of it being so tiny. And while we have a nice focus, so yeah, you have the pin header. Mine didn't come with the 0.1 inch connector. Shouldn't be a problem. You have ground, VCC, SCL, and SDA. So yeah, it's an I2C, I2C or I2C device. And yeah, since I'm using it with a Arduino Micro 5 volt, it works on 5 volt. And yeah, it should also work on 3.3 volts. On the back side, yeah, some passive components, capacitors, resistors, one diode. I have no idea what that is for, and U2, I guess 662K. Yeah, I have a look at that, what that is. Yeah, but back on the issue how to put that into a case. So that 662K on the back side, that was indeed a 3.3 volt regulator. So I guess that runs internally on 3.3 volts, but it can tolerate 5 volts at all inputs. At least it has so far. So now how can you get that into your case? So the first, I mean, if you have a bigger LCD display or LED display, you would make a cutout into your case and have the glass substrate or the display itself sticking out a bit, or have it flush, and then the board inside. Well, as you have seen, that won't fly with that little thing here. So, and I will do that in one of my projects. I'm planning to use that in my UV exposure unit, card link that I'm currently building. So you make a cutout. Yeah, details in a second. Then you press from the inside the glass substrate. To that cutout, yeah. You remember there's that flat cable, and then you have the board with the pins, hopefully cut to a length that will allow that. And yeah, I would suggest to actually, file the edges here to an angle, maybe 45 degrees, 30 degrees, 60 degrees, something like that. So your viewing angle is depending on the width of your case material, is not compromised too much. Yeah, and the display itself, that would only be this small part here. And that's exactly from the measurements I've shown you earlier. That's the line, that's the inner cutout I want to do. So these edges here. And yeah, a millimeter is a good compromise, because then you have half a millimeter wiggle room to the end of the glass substrate on one side, and on two sides basically, and to the display area, the active display area itself, on the other side. And that's a good idea, because the glass substrate is glued. Ooh, little bit of overexposure here. Let me turn that down. The glass substrate is glued to the board, as I said, and they are not very yeah, they are not very exact in doing that. You see, it's yeah, few tenths of a millimeter, sorry, sticking out on that side, and it's flush on this side. So yeah, that's why I said you have to take the measurements with a grain of sand. Sorry, salt. Um, yeah, but that's basically it regarding the module itself. Yeah, connecting it to an Arduino is really simple, I guess, for every microcontroller. Yeah, I can doodle that. So you have your on your micro somewhere your SDA pin and your S clock pin. So that's the I2C bus. So S data and S clock. And you terminate that to plus 5 volt. I use 4.7K resistors for that purpose. That's a value that works. Let's just say that. I googled a little bit what other people are using, and they are actually, depending on the data rate you're running your I2C and the length of your lines, different values might apply, but 4.7K for basically slow devices like that should be okay. And in you go to your display on the SDA and SCL, and all you need now is the ground and another 5 volts. And as I said, you can also use, instead of the 5 volts, 3.3 volts, obviously. Yeah, and I also promised you I show you a library which is working and that I like so far. Yeah, let's have a look at the notebook. So I'm using the SSD1306 ASCII library by Bill Greiman. There are newer versions available, I guess. Yeah, 1.1.3, the newest one. This has really a fantastically small footprint, okay? And plus it doesn't rely on your OLED display having a reset pin. As you have noticed, there is no reset pin here. And if you have a library that relies on the on your OLED board, on your Chinese OLED board, to have a reset pin, I think the Adafruit and the other more Western sources of OLED displays, they all have a reset pin. If the library relies on that reset pin being there and working, being there wouldn't be a problem, just, yeah, don't connect it, but rely on it working, then you might get into trouble. But as I said, this has a wonderfully small footprint. So yeah. So what I'm running currently on that board, yeah, what you saw me display right here, that is just an example from the SSD SSD1306 ASCII library called SPI 128 by 32. That should be the wire I2C 128 by 32, and it uses the Arduino wire library. Yeah, and it says here simple I2C test for eBay 128 by 64, but of course it's for 32 OLED. Yeah, and the thing has, as I said, a very small footprint. Important, the I2C address is hexadecimal 3C. Yeah, that was, let me zoom in a little bit more. Hexadecimal 3C. I hadn't have to change it, but obviously only 3C or 3D are used. You don't need a reset pin. That's very important, and yeah, the rest is just the example. Yeah, doing some prints here out to the display, one in double size. Yeah, but as I said, it's really working out of the box. I didn't have to change anything with this library, and you can start working. That's nice. And I mentioned the small footprint. Give me a second. I'm using, including the font, only 26% of my Arduino micro. Yeah. It's a micro of my Arduino micro flash memory, and only 15% of the RAM. So yeah, that's quite nice too. Also, sorry for the pumping. I'm quite, yeah, I like it. It's nice. It works with an Arduino. It's really small. It gave me absolutely no troubles, and yeah, I have two of them, so maybe I use it in another project at some time besides my UV exposure unit. So if you need a really, really tiny I2 display, that thing here is definitely for you. Yeah, with the restrictions of yeah, putting it into a case. Yeah, you have to be a little bit, yeah, put a little bit of thought into that. Yeah, and that was a review of the display. Bye.